So hello everyone, welcome to UrbanPro Live Masterclass. We are here with yet another interesting and informative masterclass for you. This is Sinchana from UrbanPro team, your host for today. Before we proceed further, we would like to inform all the attendees and YouTube viewers that UrbanPro is India's largest and most trusted learning network with over 7.5 lakh tutors and trainers. Through UrbanPro, you can easily find highly skilled and trusted personal tutors and trainers for your learning requirements. Okay, so coming back to today's session, we are presenting an interactive live masterclass on the concept electricity. But before we kickstart the presentation by our speaker, I would like to address our attendees and YouTube viewers that in case you have any questions during the presentation, please type them into the Q&A on your Zoom control panel. Moving on, for those YouTube viewers, you can drop your questions on the chat box. And don't worry about your questions, we will bring them after the presentation as we will have time for questions at the end. All right, without further ado, let's welcome our speaker, Mr. Sai Venkatraman. Mr. Sai Venkatraman is an experienced science tutor with an extensive knowledge of physics. He has been teaching students for the last 10 years. With great subject knowledge and experience, Mr. Raman is popular among his students for his unique teaching skills. So a warm welcome to UrbanPro's live masterclass, Mr. Sai Venkatraman. We're thrilled to have you
Yeah, good afternoon, students. Yeah, thank you so much to give the opportunity as UrbanPro tutor. And I'm teaching from last 15 years in physics. And most of the 10th standard students, they got 10 score in CBSE examinations. So today I came a very good chapter in front of you, that is electricity. Now, before going for electricity, we need to understand the basic concepts behind this. Yes, what is electricity? Generally, without electricity, we won't sustain. This is one of a major source everyone is required. Electricity is the most important. Children use the chat box. Without electricity, what we can do? Just use the chat box for all attendees. And just without electricity, what we can do? Even our utilities, A to Z, with help of electricity going forward. So electricity is one of the major source in our life. The class is going on with help of electricity. If electricity is not there, we can't meet here. Now, in class 10th standard CBSE, what we are going to learn today, what is electricity? And what is open circuit and closed circuit? How to define electric current? So can we use any symbols? What is the difference between potential and potential difference? And what is electrical resistance? Is there any relation between electric current, electric potential, and resistance? So these are all the subchapters in details we are going forward. Now, what is electricity? Generally, wherever we are living, our house fully glow with electricity. Assume once electricity is not there for 1 hour. So much of our work will be pending. We can't do anything. And sometimes in the streets, we are observing a big blast. There is something short circuits. So what is this phenomena? What's happening? And from where we are getting this electricity? So initially, how this electricity is formed? So these are all the basic concepts in our mind to go ahead to our chapter. Now, what is electricity? Generally, student will say, yeah, electricity is a form of energy. There are a lot of energies, different forms of energies found in the universe. Sound energy, light energy, heat energy, kinetic energy, potential energy, whatever we can able to say that there's different kinds of energies. Now, electricity is just another form of energy, a more controllable and hence convenient form. We can able to control it. So there's a reason this is the important chapter for us. Now, initially, how this electricity come up? What we made it? Benjamin Franklin, what he taken one of a glass rod and one silk cloth. You rub with glass rod and silk cloth number of times. Then this glass rod, you place a small piece of papers. He wondered, this glass rod is attracting the piece of papers. So why this piece of papers are attracted by the glass rod? Then we identified glass rod was charged. But how to prove it? Glass rod was charged. Of course, piece of papers lightweight. Some children may ask a question. Cause of lightweight, maybe unknowingly wind flow is there. Towards the glass rod, piece of papers are flowing. It may be. So for that, he taken one of a glass jar and he cut a piece of hole over here. Then he placed a rubber cork. Inside of the rubber cork, he placed one of a metal rod he placed. Then top he placed one of a metal sheet. Then he taken the gold leaves. 2 small gold leaves he taken. Why he chose that gold? Gold is a very sensitive. So his very sensitive gold leaves he placed over here. Then he placed on a table. Total air won't flow inside. Now he placed a glass rod after rubbing up the silk cloth. Then this glass rod he kept it on the plate. So what happens in the glass rod? Already glass rod was charged. The charged particles are occupying this sheet and it is transmitted to the glass rod, and both the gold leaves also occupy the same charges. Now we can find out the gold leaves are separated. Then we understood, yes, there is a charge. Yes, later on he identified glass rod is positive charge and silk cloth is negatively charged. So this is the way the charge came. Now anyone can say that the meaning of charge through chat box for all the attendees, the students. Yes, anyone can through chat. What is charge? Generally this word is there. We are using outside also. What is charge? Through chat. Use the chat box. What is charge? In newspaper also we listen. Lathi charge. What this lathi can do? It is giving an action. Yes, charge means action. School captain, he transferred to another school. He given the charges to the vice captain. So all his works is giving to the next student. Generally charge in electricity also the action. So how this action begins? Clearly we can understand about this. Now, where these electrons will get it? In class 7th standard, we defined electricity. What is electricity? What is electricity in class 7th and 8th? Generally we know flow of electrons. Flow of electrons call it as electricity. Yes. Is it really only flow of electrons? We will see. In class 9th standard chemistry, whenever we are studying, where these electrons? Every child can use the chat box freely. No problem. Now, where we are finding these electrons? In an atom. Center part is the nucleus. Electrons are revolving around the nucleus. In the same chapter we studied, the number of electrons is equal to a number of protons to exist in an atom. Yes. How many electrons are there? That many protons should be there to exist in an atom. Now, flow of electrons, which means we taken out entire the electrons. Is the atom is existed? Which won't be existed. Now, we redefined electricity in class 10 standard, the flow of charged particles. The flow of charged particles. The flow of charged particles is called it as electricity. Yes. Now, initially what they performed, just you can see this small video over here. Yes, he taken a small part of water drops over here. After placing up this iron rod, he rubbed with the iron rod with a glass rod or whatever with that silk cloth. Then whenever he is placing near to the water drops over here, you can see that the water drops are deflecting. Yes, you can see now. So what's happening? Glass rod was charged. Cause of the charges which is happening. And a simple experiment in our house, take the two candles, lit the two candles, yes, place in very nearby. What's happening? These two flames comes towards each other. At the same way, this glass rod, whenever we are charged, these water droplets are coming towards the glass rod. Yes, we can go ahead. What is current? What is electricity? Generally, whenever we are coming from school to house, we will shout against mom, Mom, current is there? Then what mom addressed? She will say fan and bulb. Yes, it is there or not. Sometimes we'll ask the same question. Mom, power is there? Again, the same phenomena to the mom. She will say the bulb and fan. And dad will give electricity bill. Can you help me to pay the electricity bill? Again, we will think about bulb and fan only. What's the meaning of these three terms for same scenario? What is current? What is power? What is electricity? The same scenario, but the different meanings over here. We won't ask to mom, flow of charged particles are there? Mom will confuse. Yes, children? Flow of charged particles is called as electricity. But we can't ask this definition. Very difficult to understand them. Current, power, electricity. These three terms generally we are using. Now, what is current? What is current? For example, airflow is coming. Airflow from higher pressure to lower pressure which is flowing. That's called as a flow of air. Another meaning is air current. If water comes from height place to the low place, then water current. If charged particles are flow from higher potential to lower potential, flow of charges, that's called as electric current. Understand? Now, how to define electric current? Electricity is different. Electric current is different. You need to understand this. Yes. What is electric current? Electric current in the sense of the flow of charged particles in unit time. There is a time mentioning. Yes. Once if you switch on the bulb, immediately within fraction of seconds, once if you switch off, we can't get electricity bill. We have to consume the charged particles in certain time. So I is equal to Q by T. Yes. Now, here, how to define electric current? The flow of charged particles in unit time. Charge symbol Q. Yes, charge symbol Q. Time T, we know that. Units of charge, we are measuring in coulombs. Yes. Hence, current I is equal to the flow of charged particles in unit time, which means charge units, coulombs, time units, seconds, electric current units, amperes. So, ampere is equal to coulomb per second. Now, CBSE, one more question here. Define electric current. We can write easily. The flow of charged particles in unit time called as electric current. I is equal to Q by T. So charge units, coulombs, time units, seconds. So SI units are amperes. Now the question they will ask, define 1 ampere. Define 1 ampere, which means 1 coulomb by 1 second is 1 ampere. How to define in a word form? The flow of 1 coulomb of charged particles in 1 second of time is called as 1 ampere. The flow of 1 coulomb of charged particles flowing in 1 second of time is called as 1 ampere. So this is the we need to define the sentence. Yes. I guess everyone understood. Just through mention through chat all the attendees. Next. Now, charge on electron. One electron having 1.6 into 10 to the power of minus 19 coulombs. Consider one electron. One electron having the charge 1.6 into 10 to the power of minus 19 coulombs. So 1 coulomb, how many electrons? This question again they'll ask. 1 coulomb, how many electrons? Means 1 by 1.6 into 10 to the power of minus 19 electrons. Yes, 1 electron, 1.6 into 10 power of minus 19 coulombs. So 1 coulomb is equal to 1 by 1.6 into 10 power of minus 19 electrons. Now, 1 by 1.6 into 10 to the power of 19 electrons. The denominator minus value, take it upwards, that is positive. Yes, 1 by 1.6 value, if you consider 0.625 into 10 to the power of 19 electrons, because 1 by 1.6 value so and so. Now, still, if you can make it to easily 6.25 into 10 to the power of 18 electrons. So, still we modified 6 into 10 to the power of 18 electrons is 1 coulomb. Yes. Yeah. Next, can I proceed? Any doubt up to here, children? Any doubt here? Just post your question. I'm ready to answer you. Just I'll wait for 30 seconds, then I'll proceed for the next slides. Any question? Yes, I can proceed. Yeah. Now let's see what you understood. Up to here, I explained a few of the concepts. Now I'm expecting result from you. You can post your chat box. Now there is a questions of CBSE. A current of 0.5 amperes is drawn by a filament of an electric bulb for 10 minutes. Find the amount of electric charge that flows through the current. A current of 0.5 amperes is drawn by the filament of an electric bulb for 10 minutes. Find the amount of charge that flows through the circuit. Option A, 100 coulombs. Option B, 200 coulombs. Option C, 300 coulombs. Option D, 400 coulombs. Choice is yours. Choice is yours. Quick. Quick. Little think. Just we explain the formula. Yes, one child, Rajesh, and the panelist is very good. Let's see how the other children. Yes, Namya, very nice. Yes. Which option we have to choose? 300 coulombs. So some children having a doubt. Sir, how come sir 300 coulombs? I is equal to Q by T formula they can able to analyze. Yes, I is equal to Q by T, sir. Now, I value 5 amperes they gave. And T value 10 minutes they gave. Now electric charge they're asking Q value. Then Q is equal to I into T. I is equal to 5 amperes into 10 minutes. So 50 coulombs has to come, but I'm not getting option. What to do? Always remember, children, whenever the time they ask in minutes, convert into seconds. So this we need to learn. 10 minutes convert into seconds. So 600 seconds. Now Q is equal to 5 into 600 seconds. Yeah. Now 0.5 amperes. This is not 5 amperes, 0.5 amperes into 600. Once if you multiply it, 300 coulombs. Option C, we have to choose it. Yes. Very nice. Next. What is the SI unit of electric current? Option A, volt. Option B, ohms. Option C, coulombs. Option D, amperes. Go ahead. Choice is yours. Already you know that. Electric current. One child is optioning all the options, but we need only one. One option out of 4. Yeah. SI unit of electric current. Once you recollect the formula, I is equal to Q by T. So finally, what is the answer? Option A, volt. Option B, ohms. Option C, coulombs. Option D, ampere. Okay. Okay. Few children's their options I'll access to you. I'll come back to you. Why you selected that? I'll judge for that. Yes, few children answered very correct. Now, just now we studied electric current I is equal to Q by T, charge units coulombs, time units seconds, electric current units amperes. If they ask SI unit of electric current, we need to mention SI units of electric current. If they ask CGS units of electric current, we have to mention the whole answer. Now, can you re-verify what's your answer? SI unit of electric current. Yes. Yes. So this is the way we have to correct our mistakes from the theory itself. Yes. Now, here, just I want to introduce one more. Electric current generally we are measuring with a meter. Yes, we will study further. Electric current we are measuring with a meter. Letter A with a circle. I'll show what is a meter. Yes. Now for this electric current units are amperes. Calculate the number of electrons constituting 1 coulomb of charge. Calculate the number of electrons constituting 1 coulomb of charge. Option A, 4 into 10 power of 18 electrons. Option B, 6 into 10 power of 18 electrons. Option C, 3 into 10 power of 18 electrons. Option D, 2 into 10 power of 18 electrons. Just now we discussed 1 electron is equal to 1.6 into 10 power of minus 18 coulombs. From that, 1 coulomb is equal to 1 by 1.6 into 10 power of minus 19. After simplifying, everyone choosing the right answer, 6 into 10 power of 8 electrons. Next, which device used to measure electric current? How to measure electric current? Yes. Electric current. Electric current. Just now we explained through the diagram. There is something. Use that. The student. Yes. Yes. Almost children, they're responding very good. That is a meter. Yes. Electric current we are measuring with a meter. Now, what is open circuit and what is closed circuit? I'm using electricity. You are using electricity. I'm in light. You're also in the light. For example, if I switch off, what happens? We can't see any object. Once we switch off, what happened? We will see what is simple circuit. Generally, we know the battery. Battery one end is the flat end, other end is a small pin will be there. Have you noticed? Generally, we are purchasing torchlight batteries or pen batteries or watch batteries or whatever. There is a small nib will be there. This indicates positive. Flat end indicates negative. Then there is a bulb. When the bulb will be on, when the bulb will be glow, we have to do something work. What is that? We have to connect with the wires. We need to choose the wires. How many wires we have to choose? 2 wires we have to choose. So from negative terminal to one terminal of the battery, from positive terminal to another terminal of the battery, fully we have to connect it. Then the bulb will be glow. Yes, this circuit we can call it as simple circuit. Simple circuit. Now, question they will ask, define simple circuit. For example, you don't know how to construct it. A small clue. Connection of battery, bulb and wires. Simple circuit. Do that, you will get 1 marks. Little technical way whenever we are doing, this battery can we call it as a source? We can call it as a source, either battery or AC or whatever. Yes. Now bulb, can we call it as an indicator? Wires, can we call it as a connectors? Yes. Now while using these three, what is simple circuit? It's a connection of source, connectors, and indicator. Call it as a simple circuit. You will get 1 mark. Next, what is open circuit and what is closed circuit? Clearly in this picture which is mentioning open circuit in the sense of there is something open-ended. We off the battery. Now flow of charged particles are not flowing, which is stopping between these two. Then this kind of circuit we can call it as open circuit. Once you can see, if it is connect, then all the charged particles will be flow, bulb will be on. Whenever we are off, charged particles will stop, then bulb will be off. Yes. Now how to define open circuit? Open-ended of source, connectors, and indicator. Open-ended of means charged particles are not connected, not flowing. That is open circuit. Closed circuit. The closed end of source, indicator, and connectors. Call it as a closed circuit. Clear, children, this concept? What is open circuit and closed circuit? Already we studied in class 8th standard. The same here. Next, circuit diagram. Generally, always I can't draw the battery with a very big space. I can't use in the examination sheet. And one name, then negative, positive. Always we can't write it. We have to use some symbols in electricity that we are going to learn now. Generally, the cell we used, cell long lead, positive, short lead, negative. Then ammeter, we discussed about ammeter to measure electric current. And voltmeter, it measures potential that we are going to study. Resistance, that also we are going to study now. Connecting wires. So once we connect all the three, that is circuit diagram. Now, what kind of symbols we are using? Say example, cell. Cell, whenever we are drawing, there should be a long lead and short lead. There should be some space between that. Long lead indicate positive, short lead indicate negative. This is a cell. Now battery. Battery are group of cells. So long lead, short lead connected to long lead, short lead, again long lead, short lead, long lead, short lead, always between some gaps we have to use it. Multiple choice questions, many times they have asked. And this is the way the combination. If we start with positive, it should be end with negative. Between positive and a negative, there should be a gaps. This is the right circuit. Sometimes what they will ask, or what they will give that question for us, like this they will stop. First also positive, last also positive. It's not a group of battery. Yes, group of cells is not that. So this type of option we should not choose. We have to choose this option only. Clear, children? Next, plug key, open switch. Open switch, this is the way. Close switch, put a small dot over here. Close switch. Wire joint, wire crossing, electric bulb, resistor, zigzag path, variable resistor, shunt resistor, ammeter, voltmeter. So these symbols we are using to complete our circuit diagrams. Now we will see what are all the materials. Cell, battery. This is open switch once we remove the key. If you remove the key, that is open switch. Once we place the key, that is closed switch. This is on and off switch. In our homes we are using. Resistors. Hope electronic gadgets, wherever it is, spoiled electronic gadgets, waste electronic gadgets, you will see this kind of color coding things. This only resistor. A rheostat. This is variable resistor. Variable resistor or rheostat, both are same. Yes, we can increase the resistance and decrease the resistance. So what is the major difference between resistor and rheostat? Number of children they'll be asked this question. This resistor is a fixed value. Resistors units ohms that we will study now. And this is a fixed value. But here at the instantaneous time, we can able to increase and decrease the resistance, that is variable resistance. Now ammeter, letter A we are mentioning. So from 0 to how much amperes we can able to measure. Voltmeter, from left hand side will come. This is multimeter, electronic shops you are observing. So with the help of this, we can measure electric current, electric potential, resistance, diode, everything we can able to do that by using multimeter. Now, the most important is electric potential and potential difference. What is electric potential and potential difference? What is potential? Generally, what is your potential? What is my potential? We will ask this question. Potential means capacity. Yes. How to measure our capacity? Simple experiment. 5 kg, 10 kg, up to 100 kg weights we placed. Small stones we placed. One boy is going and lifting. One boy can lift up to 80 kg, but 81 kg is feeling difficulty. His potential is up to 80 kg. Some children, they can lift up to 100 kg. Yes, that is his potential. Some people can't lift anything. Yes, they don't have any energy. They're very weak. So that potential is very less. Generally, potential means capacity. Now, what is electric potential? Which means with help of electricity, how much we can able to get the source. That is called as a potential. Now, you can see here, there is a charged particle we placed. One more charged particle from infinitive distance to here, you can bring. So for that, we have to do the work. Yes, work done by the moving charge particle from infinitive to this electric field region, this is called as electric potential. Yes, from infinitive distance to electric field region, if we carry any charged particle, that is called as electric potential. Clear? Now, what is potential difference? There are the two charged particles with different places. So we are bringing from charged particle from infinitive to certain region, two different places. So here the potential is different, here the potential is different. So the difference between two potentials is potential difference, nothing else. The difference between two potentials, potential difference. So how much work we are doing for that? That is potential. Of course, it's clear. Through chat, can you type it? Is it clear to you? Again, questionnaire will be start shortly. Yes, children. Hope you are understanding clearly. Yes, I'll proceed. Now, the electric potential difference is defined as the amount of work done to carrying the unit charge from one point to another in an electric field. So that is called as a potential and potential difference. So electric potential V is equal to work done by the charged particle. V is equal to work we did it on the charged particle. From infinitive distance to electric field region, we carried a charged particle. For that, we did work. This is called as electric potential. What is work units? Class 9th physics. Remember, work units, joules. Charge units, coulombs. So, what is SI units of potential? Volt. Fine. Work units, joules. Charge units, coulombs. Electric potential units, volt. Now, one more question in CBSE. Define 1 volt. 1 volt is equal to 1 joule per 1 coulomb. Yes, 1 volt is equal to 1 joule per 1 coulomb. How to define 1 volt? 1 joule of work done by 1 coulomb of charged particle called as 1 volt. 1 joule of work done by 1 coulomb of charged particle is called as 1 volt. Yes. Now, choice is yours, children. How much work is done in moving a charge of 2 coulombs across the point having a potential difference of 12 volts? I'm giving each question 1 minute time. After understanding of the theory, go ahead for the calculations. How much work is done on the moving of a charge of 2 coulombs to across the points? Potential difference is 1 volt. Yes, fast fingers. Option A, 6 joules. Option B, 3 joules. Option C, 24 joules. Option D, 12 joules. Choice is yours. Okay. Okay. Yeah. Initially, we need to understand what is the formula. Yes. Just now we discussed electric potential V is equal to work done by the charged particle. Work done by the charged particle. Now what they're asking, how much work is done? So W is equal to V into Q. Can we write V into Q? Work done, electric potential into charge. So what is charge value? 2 coulombs. What is electric potential? 12 volts. So how much work will be done? 2 into 12 is equal to 24 joules is the right option. Yes? Yes, 24 joules. Next, name the device to maintain the potential difference across a conductor. This is one of the most important question. Name a device that helps to maintain the potential difference. To maintain the potential difference, what it is? To maintain the potential difference across a conductor. Yes, option is yours. Generally, children will be choose the different answers. Yeah. To maintain the potential difference, the key point over here. What to maintain the potential difference over here? Okay. Okay. Fine. Actually, take a battery. Yes. Generally, on the battery, we are seeing 3 volts battery, 1.5 volt battery, 9 volt battery, different values we are seeing. What is volt over here? Electric potential only. Who is maintaining? Choice is yours now. So this is the we need to think. That is battery. Generally, most of the children they'll opt this voltmeter. Now the question you can see. Name the device. Name the device. Which device is used to measure potential difference? Which device is used to measure the potential difference? Measure to potential difference. Measure to potential difference. Then you are right. Very good. So maintain the potential difference is battery. Measure is voltmeter. These two questions repeatedly they'll ask. Now, which quantity is represented by joule per coulomb? Which quantity is represented by joule per coulomb? What's your answer? Which quantity is represented by joule per coulomb? Potential, work done, current, charge. Yes, option is yours. Yeah. Fine. All the children, try to participate. Be quick enough. Yes. Okay. Okay. We will see how to think about this. Which quantity? Generally, V is equal to W by Q. Work units, joules. Charge units, coulombs. So joule per coulomb. Joule per coulomb is equal to what it is? Volt. Volt means you know that what it is. Yeah. So that is potential. That is potential. Very perfectly you opted. Now, how much energy is given to each coulomb of charge passing through 6 volts battery? How much energy is giving to each coulomb of charge to pass through 6 volts battery? Yes. Very nice. Very nice, children. Very nice. Excellent. So hope you understood. What is the option? 6 joules. Yeah, 6 into 1. Yes. V is equal to W by Q. W is equal to V into Q. 1 coulomb into volt 6 joules. Now coming to electrical resistance. This is one more important over here. What is resistance? Sometimes in a playing ground, once the children are playing, we will discuss. Know that boy resistance is very less. He can't run much longer. Yes, after few meters he will be stops. He don't have any resistance power, we will say. But the same phenomena, what is there in the resistance and electricity, we will discuss. There is a conducting wire, charged particles are flowing. Already conducting wire having atoms. Atoms contains electrons, protons, and neutrons. So these existed electrons are opposing the flow of charges. That's called as resistance. So once we take a battery and a bulb, you can take it, connect it with the wires. After half an hour or 1 hour, switch off. Touch the battery, touch the bulb, touch the wires. What we are getting? Heat we are getting. Heat energy we are getting. Yes, that's the reason we are getting heat, cause of resistance. So how to define resistance? The opposition of flow of charged particles. The opposition of flow of charged particles call it as resistance. Resistance R we can indicate. Yes. Units of resistance ohms, OHM, ohms. Clear, children? Yes. Next. What is the relation between electric current, electric potential, and electric resistance? Is there any relation between these two? Electric current, ampere, electric potential, volt, resistance, ohms are the units what we discussed now. Is there any relation? Further, Ohm he proposed Ohm's law. Okay. According to Ohm's law, what he made it? He taken a battery. Yes. Battery he connected to closed switch. Whenever we connected to closed switch, of course, charged particles will be flow. So how many charged particles are flowing? We are connecting with ammeter. Ammeter to variable resistor. Variable resistor to voltmeter. Coming to fixed resistor, we connected over here. Plus, minus indicate. So this is Ohm's law circuit. Here what happened? He increased the batteries. Simple experiment we will do. Take a torchlight with one battery. Switch on. Little light will come. Take two batteries, more light will come. Three batteries, more light will come. Whenever we are increasing the batteries, light also coming more. Practically we are seeing. So whenever batteries we are increasing, that much electric current we can measure over here. So V is directly proportional to I. Directly proportional means if potential increases, electric current also will be increased. One value increases, another value will be increased. That is called as a potential. Yes. So V is directly proportional to I. This Ohm's law is applicable at room temperature. Room temperature means 28 degrees centigrade. At this room temperature, V is equal to IR. V is equal to IR is the room temperature. So at the room temperature, V is equal to IR. This is Ohm's law. Yes. Ohm's law said that the relation between I, V, R, V is directly proportional to I and V is equal to IR. This is Ohm's law. Yes. Hope everyone understood. So practically in our practical lab, we have taken that battery, then voltmeter, ammeter, yes, and indicators we can take it, variable resistors we can take it. Then we can practically we do that. That is one of a practical in our CBSE. Yes. Any queries? Any queries, children? Through chat, you can explore your questions. Hope this is very clear to you. Yes, any questions, I'm always welcome. I can able to answer your queries.
Yes, so thank you, Mr. Sai Venkatraman, for that informative session. So let's
Thank you
move
so
on
much.
to the next stage of this masterclass, that is question and answers. So now is the time for you all to post any questions that you have on any of the topic that was explained now. So you can post it in the chat box and we'll quickly take them up.
Yes, children, any questions from any topics of class 10 standard, or if you have any doubts in class 9 standard physics, most welcome. I probably everyone refreshed the subject. Clearly hope you understood electricity.
Yeah, so okay, so I hope everybody has understood, most of the topics that are taught here. So, so let's wait for another 1 minute or so at least. So if there are any questions in your minds, then please type it down. And like this is the time for you all to put up your questions. So if there are any questions, go ahead now. And once this is done, we can wind up the session. All right. So I think most of them have clearly understood the topic. So also due to time constraint, we need to wrap our session for today.
Yeah.
As we have reached to the end of the session, I would like to inform you that this session has been recorded and this will be available on UrbanPro's YouTube channel in case you want to access the recording one more time. And to connect with our speaker, book a free demo by clicking on the link shared in the chat box or in the description. I will do that again right away. Yes. So, and also to get regular updates on interactive live masterclass and informative lesson videos, do subscribe to our YouTube channel. And also your feedback is valuable for us. It will help us improve and bring topics of your choice for such master classes. So do not forget to fill up the form for session. And before we take a leave, I would like to thank our speaker, Mr. Raman, for investing his valuable time and also all the attendees for being such wonderful audience. So
Thank
thank
you
you
so much.
everyone. Stay tuned.